Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics from Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the greatest opportunity or ability to take this class. Dear students, in this odd situation of COVID-19 pandemic, we are still okay and carrying on our regular activities. So thanks to Almighty again. The most important thing we need in this unwanted situation is our awareness or proper knowledge. Yes, friend, we know we have to wash our hand frequently, we have to use our mask when we go out for emergency, and I believe only this awareness can save us from this worldwide panic. We have to discipline in our regular life, in our food habit, in our regular exercise, which can enrich our immune system. And I believe all of you are showing your respect to these rules and regulation. Right? Dear students, today we are going to discuss some important creative questions, which is very helpful for your upcoming exam. Okay, so let's see our creative questions. Right, dear students, this is our first creative question, and the scheme of this question is illustrated by two graphs. In the first figure, they show the change of distance of a moving body with respect to time. In the x-axis they plotted time, and in the y-axis they plotted distance. And in the second figure they show the change of velocity of a moving body with respect to time. And the question is selected from the board exam of Borishal Board 2019. This is our stream, and the questions are, in the first question they wanted to know what is uniform acceleration. Second question is, the position of an object with respect to a point may be changed without changing its distance. Explain. And in question C, they wanted to know, and what they said that from figure 2, that is from this figure, find the distance in 20 seconds. We have to calculate the distance of the moving body traveled in 20 seconds. And lastly, in question D, they said that give a comparative discussion of motion in different parts of figure 1 and figure 2. From both figure we have to give a comparative discussion of motion of the two body. Okay, now we are going to solve this question. Okay, dear student, we know what is acceleration. The rate of change of velocity is known as acceleration, but in case of uniform acceleration we have to say that if the rate of change of velocity of a moving body remains same for all time, then the acceleration of the body is known as uniform acceleration. Right? Now in question B, said that the position of an object with respect to a point may be changed. The position may be change of an object with respect to a point without changing its distance. Dear student, to explain this phenomena, the simplest way is that suppose we consider a point A and a particle is moving along a circular path centering A. When the particle is at point P, then the distance of the particle from A point, if denoted by 2 meter, when it moves from point Q, that is the position of the particle is changing, but the distance from point A is not changing. When the particle is moving along a circular path, then the distance of the particle always remain equal to the radius of the circle. Here AP and AQ is the radius of the circle. So distance of the particle at point P and at point Q will be same, but its position is changing, right? I hope you got it. Okay, you can explain this phenomena by the figure. Now we are going to solve question C, and in question C they wanted to know the distance traveled by the body in 20 seconds according to figure 2. Dear students, if we observe figure 2, we can see that in the figure they show the change of velocity of the body with respect to time. In first 10 seconds, the velocity of the body changes uniformly with respect to time. But in next 10 seconds, that is from 10 to 20 seconds, the velocity of the body remains same. That is, according to the figure, the velocity from the next 10 seconds is constant, and that is 30 meter per second. So if we would like to calculate the distance of the body for 20 seconds, we have to calculate the distance in two segments, because the characteristics of motion in first 20 seconds is not same. In first 10 seconds the body moves with uniform acceleration, and in second 10 seconds the body moves with uniform velocity, right? Now we are going to calculate the distance for first 10 seconds, and here we have to write from the figure. We can see that the initial velocity of the body is 0. And for first 10 seconds, final velocity V is equal to 30 meter per second, time T1 is equal to 10 second. So distance for first 10 second we can calculate it using this equation. If denoted by S1, then we can write that S1 is equal to U plus V divided by 2 multiplied by T1. U is 0, V is 30 divided by 2 multiplied by 10. Okay, after the calculation the value will be 150 meter. Okay, now we are going to solve the distance. We are going to calculate the distance for second 10 second. Here for the second 10 second, uniform velocity V is equal to 30 meter per second, time T2 is equal to 10 second. So distance for this portion, if denoted by S2 is equal to V into T2, because in case of uniform velocity we will calculate the distance using this equation. Here V is equal to 30 multiplied by 10 meter, that is 300 meter. Okay, so total distance will be for 20 second is, if denoted by S, it will be S1 plus S2, that is 150 meter plus 300 meter, right? It will be 450 meter. This is our final answer for question C. Right. Now we are going to solve question number D. In the question D, they said that we have to give a comparative discussion of motion. We have to discuss the characteristics of motion of the body described by figure 1 and figure 2. If we would like to describe the motion of the body illustrated by figure 1, in the figure 1 we can say that the displacement, the distance of the body is changing with time, and for the first 10 seconds, the distance of the body is increasing. Since the body and the nature of the graph is a straight line, so we can that the body is moving with a uniform velocity. For first 10 seconds, the body is moving with a uniform velocity, and for the second 10 seconds, the distance of the body is not changing with respect to time. So we can say that the velocity of the body was 0 for the second 10 seconds. Okay. So for first figure, for figure 1, the velocity of the body, from this portion we will be able to calculate the velocity of the body. The velocity of the body for first 10 seconds. V is equal to, here the change of distance in first 10 seconds, the distance of the body is increases from 0 to 20. So change in distance is 20 minus 0, and required time for the change of distance is 0 to 10, that is 10 minus 0. Oh, after the calculation we will get 20 by 10, that is 2 meter per second. So for first 10 seconds, the body moves with a velocity or uniform velocity of 2 meter per second, and for the second 10 seconds, the velocity second 10 second, the velocity of the body is 0. Since the distance is not changing, so we can say that the body is at rest position. So the velocity of the body is at rest. Now we are going to the characteristics of motion according to figure 2. And according to figure 2, we can see that the velocity of the body is changing with time, and the change of the velocity maintained up to first 10 seconds. Since the velocity is changing, so there is an acceleration, and for the next portion the velocity of the body remain constant, so there is no acceleration. The body is moving with a velocity of 30 meter per second, which is clear from the figure. So now we are going to describe the characteristics of motion of the body according to figure 2. Now we will calculate the acceleration of the body for first 10 seconds. For first 10 seconds, the acceleration of the body, if denoted by A, we know acceleration is equal to rate of change of velocity, that is the change of velocity divided by required time. Here the change of velocity, we know the velocity is started from 0 and it raises up to 30 meter per second within the time from 0 to 10. So here the change in velocity is 30 minus 0 and the required time is 10 minus 0. That is 30 divided by 10 or 3 meter per second square. So the motion of the body according to second figure for first 10 seconds, we can say that the body moves with an uniform acceleration of 3 meter per second, and for the next portion the body moves with an uniform velocity of 30 meter per second. Dear student, I hope you got it. Okay? Here, this is our second creative question, and the question is from Allboard 2018. According to the esteem of the question, they said that a car start from rest means the initial velocity of the car was 0. Start from rest with an acceleration of 2 meter per second for 6 seconds. That is, the acceleration maintained up to 6 seconds. Then the car moves with constant speed for 1 minute. We don't know what is the speed. The speed gained by the car after 6 seconds will be maintained for the next 1 minute. And the questions are, in the first question they wanted to know what is deceleration. In question B, show the force is a derived quantity. In question C, they said calculate the distance of the car travelled with uniform acceleration. Uniform acceleration maintained up to 6 seconds. So we have to calculate the distance of the body for first 6 seconds. And in question D, they said that if the car travels the total distance with 2 meter per second square acceleration, then what would be the required time? Right? Dear student, now we are going to solve the questions. Right. Dear students, our first question is what is deceleration? Deceleration is the opposite quantity of acceleration or positive acceleration. We know the rate of change of velocity or the rate of increase of velocity is called acceleration. So what will be in case of deceleration? So we can write that the rate of decrease of velocity of a moving body with respect to time is known as deceleration or negative acceleration. Deceleration is also known as negative acceleration, right? Now we are going to solve question B. In question B they said that show force is a derived quantity. Dear students, we know there are two types of quantities. First one is fundamental quantity. The quantity which doesn't depend on other quantities are known as fundamental quantity. There are 7 fundamental quantities. We know what are the quantities. And another type of quantities are derived quantity. The quantity which depends on other fundamental quantity are known as derived quantity. So we have to show force is a derived quantity. To show this, first we can write the mathematical expression for force. F is equal to, that means force is equal to the product of mass and acceleration. If we write mass multiplied by acceleration, acceleration is also a derived quantity. We know the rate of change of velocity is known as acceleration. So acceleration can be like that, velocity divided by time. V, velocity is also a derived quantity. Rate of change of displacement is known as velocity. So we can write that mass multiplied by velocity, that means displacement divided by time, and the t can be right in this way. So we can write that F means force is equal to m means mass, multiplied by s means displacement, divided by t multiplied by t, that means time square. So from this expression we can say that force depends on three fundamental quantities, and these are mass, this is one of the fundamental quantities, second one is displacement, and third one is time. Since force depends on three fundamental quantities, so we can write that force is a derived quantity, right? I hope you got it. Now we are going to solve question C. In question C, they told us to calculate the distance of the car traveled in with acceleration. You know, the car moves with first 6 seconds it moves with acceleration of 2 meter per second, and for the next time it moves with uniform speed for 1 minute. So we have to calculate the distance which traveled with acceleration only. So to solve this, we can write that for the first 6 seconds, initially the car starts from rest, that means initial velocity denoted by u is equal to 0 meter per second. Acceleration a is 2 meter per second square. Time t is equal to 6 seconds. So we have to calculate distance. We know s is equal to ut plus half a t square. Here this expression will be used to calculate the distance. If we use the value of the expression or quantities in the expression, u means 0 multiplied by 6 plus half multiplied by a means 2 meter per second square, that means and multiplied by t square means 6 square, and the unit of the expression will be meter. So after the calculation, this part will be 0 plus 36 meter, and the final value is 36 meter. So we can write that the car moves 36 meter with acceleration, then it moves with uniform velocity. Now we are going to solve our last question. In the question they give a condition that if the car travels the total distance with 2 meter per second square, then what would be the required time? Here we have to calculate the time for the distance which is travelled according to the step. We know what is the total distance, but we know the time. Here the parameters, using the parameter we can calculate the total distance. The car moves with uniform acceleration for first 6 seconds, then it moves with uniform velocity for next 1 minute. Using these two times, first time is 6 seconds and second time is 1 minute. In these two times it travelled to several distances. First we have to calculate the total distance using these two times. First distance which it travelled within this time already we have calculated for our question C. To solve D, the distance traveled in first 6 second is S1 is 36 meter from C. For the question C, we have already calculated it. Now we have to calculate the distance for the remaining time. For remaining time means, that means for next 1 minute. Next 1 minute it moves with uniform speed. First we have to know what is the speed. Dear student, after the acceleration, that is after the first 6 seconds, the car moves with uniform velocity. That means the velocity attained by the car after 6 seconds will maintain for the next 1 minute. So the velocity after 6 seconds will be applicable for the next 1 minute. So here velocity after 6 seconds, if denoted by V, V is equal to U plus A T1. Here U is 0, A means 2, T means 6 seconds. So after the calculation we will get 2 meter per second. This is the velocity which the car maintain for next 1 minute. So for the next 1 minute, again for next portion of motion, velocity V is equal to 12 meter per second, time T is equal to 1 minute or 60 seconds. So we have to calculate distance. Now distance traveled in next 60 seconds is, if denoted by S2, S2 is equal to V multiplied by T2. Next time is denoted by T2, that is 12 multiplied by 60, and the unit will be meter, and the final value will be 720 meter. Dear students, so total distance traveled by the car in 1 minute and 6 seconds is total distance S is equal to S1 plus S2, that means 36 meter plus 720 meter. So we can write that 756 meter. This is the total distance. So now we have to calculate the required time to travel this distance using 2 meter per second square acceleration. They say if the car travel the total distance means 756 meter using this acceleration, then what would be the required time? So for our final calculation we can write that now distance S is equal to 756 meter. Initial velocity m is equal to 0. Acceleration a is equal to 2 meter per second square. Time, required time to travel this distance is denoted by t is equal to what? We know S is equal to ut plus half a t square. The value of S is 756 meter. Value of u is equal to 0 multiplied by t plus half into 2 multiplied by t square. So after the calculation, 756 is equal to, this part will be minimized, 2 will be cancelled out, and t square, or t is equal to square root of 756. Okay. We will get t is equal to 27.49 seconds. Dear student, we can say that if the car travel the total distance with the acceleration of 2 meter per second square, then it will take 27.49 seconds rather than 1 minute 6 seconds. Okay, so this is our final answer. So dear student, I hope you got the answer or solution. If you have any confusion, you can ask me or you can ask your subject teacher. We will try to solve it. Dear students, thank you very much being with me in the time. May Allah bless all of you. Assalamu alaikum.